Hi everyone, welcome to video number 6 of Physics Mechanics, which is about circular motion. In this video, you might find some interesting surprises. There might be some things that you don't associate with circular motion, such as changing direction, that may actually involve circular motion. There also might be some things that you do associate with circular motion, but don't actually involve it, such as our Earth orbiting around the sun. That's actually an example of elliptical motion. This video will be a synthesis of many concepts that you've learned in the first 5 videos. To see how circular motion works, we're going to be exploring a physics classroom simulation, which will be linked down below in the description. In this simulation, this blue dot is going to be moving in a circle around this marked location, which is the center. So let's show the velocity vector for this blue dot. As you can see, it starts off with a velocity going downwards. If it were for this velocity vector alone, this blue dot would continue moving in a straight line downwards. So to prevent that, there also needs to be an acceleration vector pointing towards the center. So let's start the simulation. As you can see, the acceleration vector constantly points towards the center. And as we've seen in previous videos, the acceleration vector causes the velocity vector to change. In this case, the velocity vector is only changing its direction. So remember that the object always moves towards the direction its velocity vector is pointing in. And in this case, the velocity vector is changing in a way such that the object moves in a circle. If we increase the speed, in other words, the magnitude of the velocity vector, then the acceleration vector also needs to increase its magnitude in order to keep the object in circular motion. If we increase the radius, as you can see, the acceleration vector is decreasing its magnitude in order to keep the object in circular motion. If we change the mass, neither vector changes. So this is how circular motion works. Here are 3 important terms in circular motion. The first is centripetal acceleration, which is the acceleration pointing towards the center that keeps an object moving in a circle. We saw that in the simulation. It was the acceleration vector. And centripetal force is basically the same thing, except it's force instead of acceleration. Now keep in mind that centripetal force is not a type of force. It's not like gravity, normal force, tension, or friction. It's just the name that's given to the force that points towards the center. In the simulation, gravity was the force that acted as the centripetal force. The third term is tangential velocity, which is the distance an object moves around a circle over time. We also saw that in the simulation. It was the velocity vector. Here are 2 important equations. The centripetal acceleration is equal to the tangential velocity over the radius of the circle. I'm not going to prove it in this video. It's a little long. However, if you're curious, you can just search it up. And now knowing this equation and also knowing F equals ma, you can also get that the centripetal force is equal to mass times tangential velocity squared over radius. Here's a sample problem. A 1,500 kilogram car is entering a 20-meter radius turn at a tangential velocity of 10 meters per second. What is the required force of friction between the wheels and road in order to complete the turn? So here's a diagram so you understand what is going on. The car's tangential velocity wants to keep it moving forward. Therefore, the force of friction between the wheels and the road needs to point towards the center of the turn in order for the car to complete the turn. So you use the second formula that we saw earlier. The centripetal force is equal to the mass times tangential velocity squared over radius. And you get that the centripetal force is 7,500 newtons. Here's a practice problem. In this problem, gravity is the centripetal force, so you need to use the formula for gravity, which you saw in the previous video. If you forgot, you can search it up. But anyway, if you want to give this problem a try, pause the video here The solution will come in 3, 2, 1. So you just use the formula for the centripetal force and you plug the formula for the force of gravity in for the centripetal force. And keep in mind that object 1 is the satellite and object 2 is the Earth. You'll see that the variables cancel out quite nicely, leaving you with gm2 over d equals vt squared. Now you can plug in the values you know. You know that the universal gravitational constant is 6.674 times 10 to the negative 11th. The mass of Earth was given as 5.972 times 10 to the 24th. The distance between the satellite and Earth was also given as 4 times 10 to the 7th. And that is all equal to Vt squared. So then take the square root on both sides, and you'll see that Vt is equal to 3,156.63 meters per second. Here's another practice problem. For this problem, you'll really have to think about what the centripetal acceleration is. If you want to give it a try, pause the video here. The solution will come in 3, 2, 1. Here is a diagram of the roller coaster at the top of the loop. The roller coaster's tangential velocity keeps it moving forward. Gravity is the centripetal force, and it accelerates the roller coaster downwards towards the center of the loop. So we use the first formula, which is for the centripetal acceleration, and we know the acceleration due to gravity is 9.8, and we also know that the radius of the loop is 10 meters. So in the end, you're going to get that the tangential velocity is 9.899 meters per second. Now we have finished the fundamentals, and what's coming up in this video is more advanced and might not be covered in an introductory physics course. So don't worry if what you're about to see is too hard for you. We first need to introduce some more vocabulary terms, starting with period and frequency. These are two very common terms in physics. You'll see them again in a future video. Period is the number of seconds it takes to complete one cycle. Frequency is the number of cycles completed in 1 second. In other words, how frequently cycles are completed. In circular motion, one cycle is one revolution around the circle. So this is the relationship between period and frequency. Period is equal to 1 over frequency. Here's another way to see period and frequency. Period is seconds per cycle. Frequency is cycles per second. So as you can see, one of these is just the reciprocal of the other, and that's why T equals 1 over F holds. The next concept is tangential versus angular velocity. We've already seen tangential velocity. It is the distance an object moves around a circle over time. The angular velocity is the angle in radians an object moves around a circle over time. If you don't know what radians is, to convert from degrees to radians, you just multiply by pi over 180. Simple as that. Let's take a look at this diagram. The black dot starts at the rightmost point of the circle, and after 1 second, it has traveled to a new point on the circle. Theta, the angle between the ending point, the center of the circle, and the initial point, is used to determine the angular velocity. D, the length of the arc traveled, is used to determine the tangential velocity. The tangential velocity is d over time, and we can make d anything we want, but we're just going to say that the black dot is making a complete revolution around the circle. So the total distance it has traveled is the circumference of the circle, which is 2 pi r. And the time it takes to complete one revolution is just the period. So the tangential velocity is 2 pi r over the period. And if you remember the relationship between the period and frequency, you'll know that this is also equal to 2 pi r times the frequency. Now, if you don't want to remember the 2 pi r f part, then you don't have to. However, just know that remembering it can make doing some problems faster. The angular velocity is theta over time. And once again, we're going to say that The black dot makes one revolution around the circle. So the total angle it has traveled is 2 pi radians, and the time is also the period. So the angular velocity is equal to 2 pi over the period, or 2 pi times the frequency. And you might see a relationship between the tangential velocity and the angular velocity. The tangential velocity is equal to the angular velocity times the radius. Here's the list of vocabulary from this video. There's centripetal acceleration, centripetal force, period, frequency, tangential velocity, and angular velocity. Here's the list of equations from this video. Now let's do a practice problem. I know this might be challenging because there's quite a bit to memorize. So if you can't do it, don't worry. But if you want to try it, pause here. The solution will come in 3, 2, 1. So whenever you're faced with a difficult problem in physics, there is a thinking process that you can use. The first thing you should think is, what information do you already know? The problem told you that it takes 10 seconds to complete a revolution, which means that the period is 10 seconds. The problem also told you that the mass is 30 kilograms and the radius is 5 meters. The next thing you should think is, what is the variable you are trying to solve for? The problem asks for the force of friction, which is the centripetal force. The next thing to think is, what equation or equations can you use to solve for that variable? There is only one equation you can use to solve for centripetal force. The next thing to think is, are there any additional variables you need to solve for? Yes, you need to solve for the tangential velocity because you don't know it, and you need it to solve for the centripetal force. So now, if there are any additional variables you need to solve for, just go back to the third question. What equation or equations can you use to solve for that variable? And just repeat this until you can solve for the variable that the question is asking for. So now let's complete this. The equation you're supposed to use to solve for the tangential velocity is 2 pi r over t. So plugging in the values you know gives you that the tangential velocity is pi. And now you can plug it in to solve for the centripetal force, and you'll get that the centripetal force is approximately 59.22 newtons. Here's another practice problem. If you want to give it a try, pause here. The solution will come in 3, 2, 1. So once again, I'm going to use the thinking process. What information do you already know? You know the tangential velocity and the centripetal acceleration. What is the variable you're trying to solve for? The angular velocity. What equation or equations can you use to solve for that variable? There are two equations, but the first one, which is angular velocity equals 2 pi r over t, is probably not that efficient because there are two variables, r and t, which you don't know. So you should usually choose the one that has the fewer unknown variables. So if you choose tangential velocity equals angular velocity times the radius, then there's only one unknown, which is the radius. And now the radius is an additional variable that you need to solve for. So you should go back and think about, what equation or equations can you use to solve for that variable? So the equation you're supposed to use to solve for the radius is the centripetal acceleration is equal to tangential velocity over the radius. So plugging the values in, you get that the radius is 3.840 times 10 to the 8th meters. And then plugging that in to tangential velocity equals angular velocity times radius, you can solve to get that the angular velocity is 2.66 times 10 to the negative 6 radians per second. So I hope this video was really helpful. The most important things to remember are centripetal acceleration, centripetal force, tangential velocity, and the two equations involving those variables. If you have remembered those, then you can try to remember period, frequency, angular velocity, and the other four equations. It is also useful to remember the thinking process. That way, it can help you if you encounter any difficult physics problem in the future. Thanks for watching. I'll see you in video number 7.